Now let's go ahead and take a look at this review. In this first question, we see something in the form of absolute value of x minus 2, which is of the form a absolute value of x minus h plus k, right? So notice that we already have the minus sign that we're looking for, so we don't need to rewrite this at all. It wouldn't become minus -2 because we already have the minus sign. So our h is 2. So when our h is positive, it's going to move it right by 2, okay? So the only graph that moves it right by 2 is this one. Okay. In this one, it is following the a absolute value of a x minus h plus k again. But now we have a number on the outside, which is your k. And so notice that k is -2. So it's going to go down by 2. Okay, this is the only graph that goes down by 2. Okay, in this next question, we have the absolute value of negative absolute value of x minus 1 minus 2. So again, this follows a x minus h plus k rule again, where the a is -1, or if you want to think about it separately, right, the negative means reflection and the a is 1. So the negative is a reflection in the x-axis. Okay. The h, because we already have the minus sign that we're looking for, we don't need to write this as x minus -1. We already have the minus sign, so it's just h is going to be 1. Okay, and that means move it right by 1. Okay, and then the -2 on the end, which is your k, is going to be -2 or -2, so down by 2. Okay, so the negative is reflection, so all these graphs are reflected, right? They're all facing upside down, right? Instead of being a sharp V, they're an upside down sharp V. Now we need to look for a graph that moves right by 1. This one moves left from this spot. This moves left, so it can't be that one. This one moves left also, so it can't be that one. This one does move right, and this one does move right from these origins points. And then we need to look for a graph that goes down by 2. So then this one goes down by 2, but this one goes up by 2, so it can't be that one. So, all right. So in number 4, we need to evaluate the function when x is -4. So we need to look at these 3 things, right? Is -4 less than or equal to -3, which is true. It would be that one. But just to make sure, is -4 between -3 and 1? No. And is -4 greater than 1? No, because negatives are not greater than positives, so it can't be that one. So what we're going to do is we're going to take this -4 and we're going to plug it into here. So our function of -x minus 1, we'll say -4 minus 1. -4 is +4 minus 1, which is 3. Alright, so in number 5, it's asking us to graph a piecewise function, right? When they give us more than one function, they ask us to graph it depending on its constraints, right? So as long as x is less than 0, our graph is going to follow x minus 2. So x is less than 0. We know that 0 is here, right? Okay. X minus 2 means that you have a slope of +1 and a y-intercept of -2. So your y-intercept should be -2, which is here and here. This one doesn't touch the y-intercept of -2, so it can't be that one, right? And this one doesn't touch the y-intercept of -2, so it can't be this one either. And then if we know that it's one of these two, let's take a look at the 3x. So the 3x means go up by 3 and over 1, starting from a 3x plus 0. So starting at 0, so go up by 3 over 1, that's what slope of 3 is. This one also follows that, so going up by 1, 2, 3, and then over 1. So both of these graphs work. So what we need to do is we need to look at the domain and range. Domain is all the x values. So if we look at it, all the x values are covered because all the x values going this way are covered, and all the x values going this way are covered. Like these lines go on forever. Range is all real numbers. If we notice that there's a gap in here on the y values, so it couldn't be all real numbers because it's not including anything. Well, it is including 0, but it's not including like -0.0001, right? And then it's not including -2, so there's not going to be all real numbers, so we can't really say it's that one. Domain is all real numbers because it covers all the x values on this side and all the x values on that side. Range, everything less than -2, which makes sense. It's everything that's below this -2 line. And then greater than or equal to 0, so it is true. It's this. Okay. In the next question, all we got to do is find the inverse of the relations, meaning switch the x and the y's, right? So let's just flip all the points. It would become 4, -7, 1, -7, 0, 0, 1, 7, and 10, 4, 10. Okay, so just flipping all these points gives us our inverse. The same thing can be said for this. -8, 2 would become 2, -8. Okay, -2, 1 would become 1, -2. 0, 0, flipped again would be 0, 0. And then 2, 1, flipped would be 1, 2. And then 8, 2, flipped would be 2, 8. Okay, so all we got to do is switch the x's and the y's. In this question, number 8, it says the third root of negative 729. So what we could do is we could separate it as the third root of -1 and the third root of 729. The third root of -1, what we want is three numbers that multiply to make -1, and we notice that -1 times -1 times -1 makes -1, so this part of it would just be -1. So then let's take the 729 and start to break it down. Okay, I'll use 9 and 81, and then I'll use 9 and 9 again. Okay, you could also go further and say 3, 3, 3, and 3, and this is 3 and 3 also. Okay, so in here we'd have 3 times 3 times 3 times 3 times 3 times 3. Okay, and this 3 inside the hook is telling us to circle groups of 3. So we have a group of 3 there, so let's pull that one out, and a group of 3 here, so let's pull 1 out to represent that group. And then we have this -1 all along from this part, so -1 times 3 times 3 is -9. Okay, let's go ahead and take a look at the next question. The next question is a lot alike to the last one. If we notice it's in this form of a to the 1 over n, we can switch it and put it into n root a. Okay, so this would be 3 root 64. So the third root of 64 means let's take 64 and let's start breaking it down as 8 and 8, and then this is 4 and 2, and this is 4 and 2 also, and then 4 is 2 and 2. Okay, so we have all these 2's. There's 6 of them, so 3 root 2 times 2 times 2 times 2 times 2 times 2. And then let's circle groups of 3 because that's what the 3 is telling us. So 3 there and 3 there. For every group we can take out 1, so take out 1 for that one, take out 1 for this one, and we get 2 times 2 is 4. Okay, let's go and take a look at this question, which is a lot like it just has a 4 on top of the exponent. So what we notice is that we need a 1 on top of the fraction in the exponent, but this one has a 4. So we can rewrite it as 64 to the 1/3 with a 4 on the exponent outside because this is saying 1/3 times 4, which is 4/3. We just broke it down to have a 1/3, which is what we wanted. Okay, so then the 64 to the 1/3 is exactly what we just did in the last question. So I'll just put it in there. And you can see that the math that we did to figure out this part is all here still. It's the same thing. And then we have this 4. So 4 to the 4th is, in your calculator, 256. It's 4 times 4 times 4 times 4. Okay, so number 11 says q to the 0. Anything to 0 power is 1, so all we got to write is 1. The next one follows these negative exponent rules that says if you have a negative exponent on the top, write it on the bottom. If you have a negative exponent on the top, write it on the bottom. If you have a negative exponent on the bottom, write it on the top. So let's go ahead and do that. So a to the -2, we would write on the bottom with a +2. R to the -8, we would write on the bottom with a +8. S to the -10, we would write on top with a +10. So then S to the 10 over 64, R to the 8, and that's your good answer. Okay. So in this next question, we have b to the 3rd times b to the 8. Okay, so what we need to do is because we're multiplying the same base, which is just b, can add our exponents, right? So b to the 3 plus 8 which is b to the 11. Okay, so think about it like you were foiling, like in chapter 2, when you learn how to FOIL. When we FOIL these two things, we do add up the exponents, right? So remember that. So this n root a, right, is the same thing as what we had right here. So when it says find the real nth roots of a, you're going to use this stuff again, right? And so this is n, which goes in the hook. The a is 729. So let's break that down, which we actually had already done in number 8. We had done this already, but let's look at it really quickly again. So 729 broken down can be 9 and 81. This is 9 and 9. This can be 3 and 3, and this is also 3 and 3. This is also 3 and 3. Okay, so 3 root, we have 1, 2, 3, 4, 5, 6 threes, right? So 3 times 3 times 3 times 3 times 3 times 3, right? And then the 3 inside the hook is telling us to circle groups of 3s. Okay, so for every group we can pull out 1. So 3 times 3, which is 9. Okay, so there's your answer to 14. Okay, same idea for number 16. It's a lot easier because we know what the square root of 16 is, and we know that it's going to have two answers, right? Positive and negative of that number. So if we wanted to, we could see it again. 16 is the same thing as 4 and 4. 4 is the same thing as 2 and 2, right? So then this would be 2 root 2 times 2 times 2 times 2. And so circling groups of 2, we have the group of 2 here, and we have a group of 2 here, right? So 2 times 2 is 4, but then we also recognize that the n was even and the a is bigger than 0, so it would be positive and negative 4. Okay, this one in number 16 says n root a, which is going to be 2 root negative 49, and what we need to recognize is that you can't have a negative a if you have an even n, right? So this is going to be no real solutions. You'll have imaginary solutions, but it doesn't have any real solutions, so that's what we need to say. Okay, so for number 17, we have 1 over 9, and technically, if you wanted to think about it like that, it's 1 over 9, x to the 0, and to find the degree of the monomial, you need to add the exponents attached to any letters. So if the exponent is just 0, then our answer to this question is 0. Okay, so then in the next question, adding the exponents attached to any letters, we get 4 plus 2, right? So 4 plus 2 is 6. Okay, in finding the sum, it's really just adding across like terms, right? You can't add the exponents, so like you'll keep the exponents the same. So like this is 1 and this is 1. You're not going to add them and make it 2, right? In addition, we're just combining the coefficients in front of the variables. So y to the 1, y to the 1, all we're doing is adding the 1y, because this is what 1 it is, right? 1y plus 5 plus 3y minus 9. Okay, so we're going to add 1 plus 3, which is 4y, and we're going to add 5 minus 9, which is minus 4. Okay, same idea in this next one. We see that we have a negative 1, right? Because the negative g squared means negative 1g squared plus 3g squared, which adds to 2g squared. Okay, and then we have a negative 4g plus 9g, which negative 4 plus 9 is 5. So we're not adding the exponents again, we're just adding the coefficients in front of them, like that. And then we have a minus 2 hanging out by itself, so it's just adding on to the end. All right, so with finding the difference, there's one thing we need to do before we can just combine them, and that's distributing this negative to everything inside of it. Okay, so this would become 2x squared plus 6x minus 11 minus 5x squared plus x minus 7. Okay, and so now we can just combine like terms like we did in the last two questions. So 2x squared minus 5x squared, all we got to do is combine the coefficients, and 2 minus 5 is negative 3x squared. Okay, 6x plus 1x, because that's what that is, that's a 1x, so 6x plus 1x is 7x. And then combining the last things, we get negative 11 minus 7, and negative 11 minus this one with this one. And then we'll make this one have 3 lines under it. Negative 11 minus 7 is negative 18. go ahead and take a look at the next page. Again, just distribute the negative sign. And we get 2k squared plus 4 minus 4k squared plus 2k minus 6. Okay, and then let's go ahead and combine like terms. And we get 2k squared minus 4k squared, which is negative 2k squared. We get 4 plus negative 6, which we'll put right here. And that's negative 2. And then the 2k. Alright, so in the next questions, we're going to be finding the product, which means foiling, or if you want to use the box method, it's up to you. In our case right now, I'll just use FOIL, but it's your choice. So m times 9m is 9m squared. M times negative 1 is negative 1m. Negative 7 times 9m is negative 63m. And negative 7 times negative 1 is plus 7. And then all we got to do is combine these two. We get 9m squared minus 64m plus 7. In the next question, we can go and do the same thing. So 9 times 4 is 36. 9 times s is 9s. 4s times 4 is 16s. And 4s times s is 4s squared. Okay, so combining, all we got to do is combine these two. And that becomes 25s, right? Don't get them confused with 5s. Just know that they're s's. So 9s plus 16s is 25s. And then 4s squared. Okay. So then also you might just want to write, well, you should write this in standard form, which means from exponents on the variables going from highest to lowest. So 25s plus 36. Okay, so the next two questions are going to be basically foiling, also just multiplying across, but multiplying 3 terms in one parentheses to the other 2 in the other one. Okay, so n squared times negative 1 is negative n squared. N squared times n is n to the third. 6n times negative 1 is negative 6n. 6n times n is 6n squared. Negative 4 times negative 1 is plus 4. And negative 4 times n is negative 4n. Okay, so now just combining like terms and also putting it in order of exponent going from highest to lowest. So the highest exponent we have is n to the third, so we'll write that first. Then we have two n squared terms, and so negative 1 plus 6 is plus 5n squared. Negative 6n minus 4n. So this one makes negative 10n and plus 4. Okay. Next question is exactly the same as what we just did. So x times x squared is x to the third. X times negative 8x is negative 8x squared. X times 2 is 2x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 8x is plus 24x. Again, that's an x, so don't get that confused. Negative 3 times 2 is minus 6. Okay, so now all we got to do is combine like terms, and we see there's no other x to the third term, so we'll just write that. There is a negative 8x squared term and a negative 3x squared term, so negative 8 minus 3 is negative 11x squared. Positive 2x plus 24x is plus 26x, and then minus 6 at the end. Okay, so that's good. All right, so then b minus 11 squared is the same thing as b minus 11. That's a b minus 11 times b minus 11. So we have 2 of the same term multiplied together. Okay, you could use your a squared minus 2ab plus b squared rule, or you could FOIL it out like we've been doing. Just to keep the consistency, let's go ahead and do it the same way that we've been doing. B times b is b squared. B times negative 11 is negative 11b. Negative 11 times b is negative 11b. And negative 11 times negative 11 is plus 121. Okay. What you notice is that we can combine these two things, and so negative 11 minus 11 is negative 22, and they had a b, so b squared minus 22b plus 121. Okay, so this does follow the a squared minus 2ab plus b squared rule. Okay. In this next one, it's gonna end up following your a plus b, a minus b, but it's not written that way right now. If you wanted to do that, you could rewrite it as 6 minus 5m and 6 plus 5m, and use your a squared minus b squared rule, which I'll show you using that way. But you could also just FOIL it and do it that way. So the same way that we've been doing these questions before, you could do it that way also. All right. So if we wanted to do the a plus b, a minus b, notice that the minus sign is here, but it should be here. So all we got to do is rewrite this, and if we rewrite this, we're going to have to rewrite this one also. So this becomes 6 minus 5m and 6 plus 5m. Okay, so a is 6, because now we have a minus b, a plus b, so a minus sign and a plus sign with the same terms in each of them, right? So a is 6 and b is 5m. So a squared minus b squared becomes 6 squared minus b is 5m squared. So again, that's a 6. So 6 squared is 36. And then 5 squared is 25. M squared is m squared. Okay, so this answer should say 36 minus 25 m squared. And if you would have FOILed it out, you would have got 36 minus 25 m squared also. Okay, so when it says solve the equation in number 29, all you got to do is set each part equal to 0. So t equals 0 and t plus 5 equals 0. Whatever's inside the parentheses, set it equal to 0, and whatever's like in front of a parentheses, as long as it has a t or a variable, set it equal to 0. So t equals 0 and t would equal negative 5, right? Subtracting it to the other side. Okay, so this right here is p plus 8 times p plus 8. We just talked about that a little while back, right here. When it has a square term, it's just the same term multiplied by itself again. So this is going to be p plus 8 times p plus 8 equals to 0. So we notice that we can set both of those equal to 0, even though it's the same thing. Okay, it would just be called like a double root. So p equals negative 8 and p equals negative 8. Okay, so negative 8 is your answer to both of these parts. Okay, now in this next one, it's going to be z equals 0, z plus 9 equals 0, and 4z plus 2 equals 0. Okay, so z plus 9 equals 0 will be z equals negative 9. 4z plus 2 equals 0, that would be 4z equals negative 2. Subtracting the 2 over, and then dividing everything by 4. We get z equals, and then this is negative 1/2. Okay. So in the next question, we want to get everything on one side. So we would have to add the 27n onto this side. And we would get 11n squared plus 27n equals to 0. Okay, 11 and 27 don't have any numbers in common that we can take out of it, but they both have an n, and the n that they have in common is n to the 1. So let's take out an n to the 1 from both. 11 divided by 1 is, because we technically took out 1n, but that's whatever, you don't have to write like that. And then n squared divided by n to the 1, subtract the 2 and the 1, we get 1. So 11n. 27 divided by 1 is 27. And n divided by n, 1 minus 1 is 0, so don't write any n's on there now. Equals 0. So n equals 0 based on this part, and 11n plus 27 equals 0. Okay, so subtracting 27, we get 11n equals negative 27, and then dividing everything by 11, we get n equals negative 27 divided by 11. So we got n equals 0 and n equals negative 27 over 11. Right. Let's go ahead and do the same thing with number 33. We want to get everything on one side. So let's move it over here. We would get 49x squared minus 25 equals 0. And if you notice, it follows the a squared minus b squared rule, where a, taking the square root of everything in here, we get 7x squared minus the square root of 25 is 5 squared, and setting that equal to 0. So 7x squared minus 5 squared equals 0. So that follows your a plus a squared minus b squared. So this would be a plus b, 7x plus 5, and 7x minus 5. Okay, equals to 0. All right, and so then solving 7x plus 5 equals to 0. And say 7x minus 5 equals to 0. Okay, so subtracting this 5 to the other side, we get 7x equals negative 5. And divided by 7, we get x equals negative 5 over 7. Okay, and then same thing with this one, adding the 5 over, we get 7x equals 5. And then dividing everything by 7, we get x equals 5 over 7. That's a 7. Okay, let's go and do these two questions over here. So I'll do 34 right here. S squared plus 18s plus 81. Okay, this is going to use the big X method, so let's go ahead and set that up. AC is going to be 1, which is A is 1, C is 81, so AC is 81, and B is 18. Okay, so we want two numbers that add to 18 and multiply to make 81, and that would be 9 and 9, because 9 times 9 is 81, and 9 plus 9 is 18. So in here, we're going to put the 1s term in here, and say 1s plus 9. We're going to put the 1s term in here, and we're going to put the 9 in here also. And so it'd be 1s plus 9, 1s plus 9. But if you want to write it, you could write it as s plus 9 squared. Okay, let's go ahead and do 35, which also follows the a squared minus b squared rule. So z squared minus 49 equals 0. This would be z squared minus 7 squared equals 0. So this does follow the a squared minus b squared rule, right? We just got to take the square root of both things and put it into there. So a is z, so z plus 7, and then b is 7, so then z minus 7 equals to 0. So z plus 7 equals to 0, and z minus 7 equals to 0. Subtracting 7 to the other side, we get z equals negative 7. Adding 7 to the other side, we get z equals positive 7. So that's 35. All right. Let's go and take a look at this next question, 36. What we see is that they have a 2 in common, so we can take a 2 out of both of them. They also have a k, and the k that they have in common is a k to the 1, right? That's the most k's that this one has, so let's take a k out of both of them also. When we take a 2 out of 2, so 2 divided by 2 is 1. K to the 3 divided by k to the 1. 3 minus 1 is 2, so this would be k squared. 32, or negative 32 divided by 2 is negative 16. And k to the 1 divided by k to the 1 is 1 minus 1, which is 0. So this would be 2k. Taking the square root of this, we get k squared. Taking the square root of this, we get 4 squared. Okay, so this is really 2k times k plus 4, k minus 4. Okay, and so then 2k equals 0. So k would equal 0. K plus 4 equals 0. So k would equal negative 4. And k minus 4 would equal 0. So k would equal positive 4. Okay, so just setting h bar equal to 0 and solving for k. In this next one, we're going to use square roots. So taking the square root of both sides. So 2x plus 10 squared equals 16. Taking the square root of both sides, we know that the squares on this side would cancel. So we would have 2x plus 10. And the square root of 16 is 4, but it's also plus or minus 4. Okay, so remember that if you take the square root of a number bigger than 0, it's going to have two answers. So 2x plus 10 equals 4. And 2x plus 10 equals negative 4. Okay, so subtracting 10 to the other side, we get 2x equals negative 6. Dividing both sides by 2, we get x equals negative 3. Okay, and then same thing here. So 2x, subtracting 10, we get 2x equals negative 14. Dividing both sides by 2, we get x equals negative 7. All right, let's go ahead and solve this question number 38. I'm going to choose to use the quadratic formula just to show it to you. So let's go ahead and use the quadratic formula, which has negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if we added the 10 to this side, what the equation would become is 4x squared plus 5x plus 10. Okay, so negative b is 5, so negative, plugging in 5 in parentheses, so we know that that's what we put in there, plus or minus the square root of b squared, so 5 squared, minus 4 times a is 4, and c is 10, all over 2 times a, and a is 4. Okay, so simplifying this, we get negative 5 plus or minus the square root of 25 minus 4 times 4 is negative 16, and negative 16 times 10 is negative 160. Okay, over 2 times 4, which is 8. Okay, 25 minus 160 is negative 135. So negative 5 plus or minus the square root of negative 135 over 8. And what we notice is that this number in here is a negative. So if this is a negative number inside the square root, this is going to have no real solution. Okay, and so we can stop there and say that it will have no real solution just because there's a negative inside the square root. Okay, let's go ahead and take a look at 39. So if we rewrote this equation, it would say 4x squared minus 16x plus 15 equals 0, whatever, right? Adding the 15 over is how we got this. Okay, so putting it into negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to have to use a quadratic formula to do this. Okay. And if you wanted to, you could likely just use the big X method, where AC is 60. So two numbers that multiplied would make 60, and add to make negative 16, which would be negative 10 and negative 6. But I'm going to use this method just so you guys have seen it. So negative b is negative 16, plus or minus the square root of b squared, which is negative 16 squared, minus 4 times a is 4, and c is going to be 15. Okay, all over 2 times a, which a is 4. Okay, so this becomes 16 plus or minus the square root of negative 16 squared is 256. Squared is 256 minus 4 times 4, which is negative 16 times 15. So negative 16 times 15 is negative 240. Okay, and this is all over 8. Okay. So 256 minus 240 is 16, so it would be 16 plus or minus the square root of 16. I'll divide by 8. And then square root of 16 is 4, so 16 plus or minus 4 divided by 8. And that would be 16 plus 4 is 20 divided by 8. So one answer would be 20 divided by 8 because we did 16 plus 4 divided by 8, which would simplify. They can both be divided by 4, so this could be the same thing as 5 over 2. Okay. And then the other one would be 16 minus 4, which is 12 divided by 8. And they can both be divided by 4 also, so 3 over 2. Okay, so those are our answers to number 39. In the next question, all we got to do is factor. We don't have to set it equal to 0, so this is going to be a little bit nicer because it's just the first part of what we were doing. So these both numbers have a 6 in common, so let's take that out. The z's that they have in common is z to the 1, right? So let's take out a z from both things. 6 divided by 6 is 1. Z squared divided by z, 2 minus 1, right, is 1, so that would be z to the 1. Negative 42 divided by 6 is minus 7. And z to the 1 divided by z to the 1, 1 minus 1 is 0, so that's your answer. Okay. In this next question, we're going to use the big X method, where AC is 1 times 21, and B is negative 10. So we want two numbers that multiply to make 21 and add to make negative 10, which would be negative 7 and minus 3. This 1x term, we're going to put into our parentheses, and we're going to say 1x minus 7 and 1x minus 3. This next one, we can take a 7 out of everything, so we're going to go ahead and do that. So before we do anything else, notice if you have a number in everything, so you can pull it out first before you do anything. Okay, so this would be k squared. 7 divided by 7 is 1, so we are left with k squared. Negative 91 divided by 7 is 13, so this would be negative 13k. And 84 divided by 7 is 12. Okay, so if we use our big X method, what we're looking for is two numbers that multiply to make 1 times 12, which is 12, and add to make negative 13. Okay, so AC is 12, and B is negative 13. Okay, so what two numbers multiply to make 12 and add to make negative 13? Negative 12 and negative 1. Okay, so we're going to take these numbers, and we're going to put them into here. So because this was a 1k term, we're going to put a 1k in here and here. All right, 1k in both. And then the minus 12 can go into this one, and the minus 1 can go into this one. And then you have your answer. All right, so in the next question, we have 4x squared minus 13x plus 3. Because you can't take anything out, we're just going to use our big X method already. Say that AC is 4 times 3, which is 12, and B is negative 13, which, if you look at it, we already did that in the last question. So negative 12 and negative 1, right? Because same as this one. And then what's going to happen is because we didn't, this was not a 1x term like it was in the last couple of questions that we did, we're going to put a 4x in here and in here, right? And then we're going to put the minus 12 in here and the minus 1 in here. So out of 4x and out of 4 and 12, is there any number that they have in common? Yeah, they both can be divided by 4. So let's do that. So x minus 3, and this one is b 4x minus